Hi, I'm Kelly McFarland.
And I'm Katrina Hansen.
And today we're exploring two very exciting circuits.
Both of them have 3 resistors, but one of the circuits is in series and one is in parallel. This is a simulation of a circuit with 3 1K resistors and a 12-volt power supply. If we use our voltmeter to measure the voltage before the first resistor, we see that there are 12 volts. If we measure the voltage after the first resistor, we see 8 volts. After the second resistor, 4 volts. And after the third, 0. Now we can switch to an amp meter and measure the current at the power supply, which is -4 milliamps, at the first resistor, which gives us 4 milliamps, the second resistor, also 4 milliamps, and 4 milliamps across the third resistor as well. Okay, here is our circuit that we made. It has 3 resistors, and if we measure from ground, there we can see that our power supply is set to 12 volts, and each of our resistors is 1K. So we believe that because there are 3 resistors in series, that the 3 resistors will take equal amounts of the voltage potential.
Okay, so here at the beginning of the first resistor, the potential would still be 12 volts. After the first resistor, the potential drops to 8 volts. After the second resistor, it drops to 4 volts. And at the end of the last resistor, it is 0, which is basically equal to ground. Here we're measuring current in our series circuit, and we're at 4 milliamps between the second and third resistor.
And between the first and second resistors in our circuit, the current is again 4 milliamps.
Here we're measuring the current between the power supply and the first resistor, and once again it's 4 milliamps. Here we have a parallel circuit with 3 resistors, each 1K in parallel. Our voltage before the first resistor is 12 volts. In between the first and second resistor is also 12 volts. And in between the second and third resistor, it's also 12 volts. The total current at the power supply is 36 milliamps. Over the first resistor, the current is 12 milliamps. Over the second resistor, it's also 12 milliamps. And over the third resistor, it's also 12 milliamps. Okay, so here we have a parallel circuit with 3 resistors that are each 1K each. The total potential for the circuit is 12.06 volts. Now we're going to measure it across each resistor. So the first resistor, we have 12.06 volts. The second, got the 12 volts. And the third, we also have 12 volts. So we know it would be a parallel circuit since the voltage is the same throughout. Here we're measuring the current in our parallel circuit, and between the second and third resistor, we get a reading of 12.2 milliamps.
Between the first and second resistor in our circuit, we also get a reading of 12.2 milliamps. Between the power supply and our first resistor, we get a reading of 12.1 milliamps. Finally, at our power supply, we get a reading of 36.6 milliamps. This makes sense because 12.2 milliamps times 3 equals 36.6.
So, I hate these leads, and I prefer just banana cables with alligator clips in there, because then you can just grab them.